So today I'm going to be showing you how to do logistic regression in SAS with multiple variables that have, I guess, continuous and categorical variables. This is looking at the relationship between some kind of cancer as the outcome and various demographic factors such as age, weight, race, and smoking. For race, I think I coded it as 1 as white, 2 as black, and 3 as other. And for smoking, 1 is smoking positive, and for cancer, 1 is cancer positive. I forget what this data was for originally, so I don't know what type of cancer it is, and I actually don't even really know how to anticipate these relationships, so this will be interesting. Yeah, so you can use proc logistic or proc GLM. I prefer proc logistic because it is better for a few reasons. It gives you the odds ratio without you even needing to ask it. It's easier to also do estimates and contrasts and stuff like that. And I'm pretty sure automated selection is also an option here for proc logistic. So yeah, I'm not going to show you the preliminary analysis or the diagnostics because I did videos on preliminary analysis already, and I'm hoping to do a diagnostics one on its own because it's pretty applicable to all kinds of regression. But yeah, just here I'm just going to show you the ins and outs of proc logistic. There's a lot more things it can do than what I'm going to show you, but yeah, so let's get started. So if we're just going to show, like, let's just say a relationship of interest is smoking and cancer, we can set up a frequency table just to show what that bivariate analysis is, because that's enough to get an odds ratio or a relative risk depending on how rare our outcome is. So we can do proc freak data. I think I called it logistic table. I sometimes forget the rules of the table statement, so let's see what it gives us as it is. Okay, so there's a few things we want different. We want cancer up here, and also we want the 1 in this column. So what we can do is switch the orientation of smoking and cancer, and we can also tell SAS to order differently. 1 second. Wait a second. Okay. Data. Okay, so let's see now. Okay, so it looks like what I told SAS to do here was order it the way it appears in the data, and the way it is 0 first, and that's not what we want. So what we can do, so order equals data does what we want it to do, is we can sort data equals stick, and we can sort by cancer, by, and I put descending in there because then it's going to go in reverse order. If it's alphabetical, that's Z to A, but in number wise it's 1 to 0. So let's make sure this did what we wanted it to do. Yeah, now 1 is what shows up first, so this should produce the table we want now. Yep. Okay, cool. So there's one more oh, I don't want percent either. Yeah, bear with me. I'm probably not going to edit this out because there's probably someone who might eventually watch this who finds this useful. So yeah, here now we have our table. These should be integers, shouldn't they? Oh, I have no frequency. Okay. So we should be good now. Okay, nice. So now we have our counts for each of these combinations of smoking and cancer, and that's enough to do an odds ratio or a relative risk. So we can ask for that. Okay, so yeah, we're able to get an odds ratio, which I guess the way this would be calculated would be among this exposed group, cancer positive divided by negative divided by among the non-smoking group, cancer positive divided by negative, and relative risk, instead of dividing by the negative, you divide by the total. It's a proportion rather than odds. And the fact that these are different tells us that the odds ratio isn't a good approximation of the relative risk. That's probably because cancer isn't rare enough. So yeah, odds ratio is what we'll probably use because that's the safer bet, I think. Yeah. Wow, cancer is really. I guess. I think this data was originally for something else, because here I have cancer even being more common in the non-smoking group. But yeah, don't worry about that. That's just yeah, that's basically, this is just to show you how to do proc logistic. So yeah, keep that in mind, because the reason I showed you that is because with logistic regression, we're basically doing this while controlling for other variables. So this is like the crude relationship between smoking and cancer without controlling for any of these other variables we have. And I'll show you how proc logistic with just smoking and cancer involved in the relationship should come up with a pretty similar answer. So let's see. So proc logistic, it has a lot of the same rules as like proc reg and proc GLM. Actually, not so much proc reg, just because proc logistic is good at dealing with it creates its own dummy variables. Data equals logistic. What a class statement. Let's just start with smoking, just so I can show you that it should give a similar answer. So smoking, and we should just tell it that we want the referent to be 0. And yeah, cancer equals smoking. And what it's probably gonna do, it's not gonna be the same answer right away. Oh, what did I do wrong? Oh, it's just called smoke. Oh, sorry, yeah, smoking came up twice. Wasting time. Okay, cool. So, yeah, it chose probability of cancer being 0 automatically, and that bugs me that that's something that SAS does, because we rarely want the probability of a non-event. So there's two things we can do. We can put descending, and that'll accomplish what we want. It'll make the outcome now cancer equals 1. But what I find kind of more intuitive is to the same way we manually assign the referent here, we can manually assign event. Yeah, and that should also do it. Yeah. Yeah, I don't want design variables. I think I should be able to do Okay, nice. Yeah, so now if I run these two things together, they should give a pretty similar answer. So we have an odds ratio here of 2.02, and the results of our logistic regression will come out. We have our betas here, and for smoking versus not smoking, it's the same, 2.02. One thing that's nice is, it does give you 99 confidence, but yeah, like basically how you'd compute it by hand usually, and that doesn't give you a confidence limit or tell you whether it's significant. So that's an example where just a piece of paper and a 2x2 table is more limited than doing this in software, because you can see if it's significant, where here it doesn't cover it, but yeah, it's barely significant. But yeah, let's fit more things into this. Yeah, we have other variables to work with. Let's say we want to control for age and race, and weight. We can control for all of those things. Race. I think I already formatted this, so. Race. No, that's why. Okay, cool. Smoke, race, weight, age, and that should give us a complete model here. Yep. Things aren't, actually, a lot significant, but not everything. Age here doesn't look like it's fitting, or it looks like it could be removed unless we thought it was a confounder. And yeah, we have these estimates where being a smoker increases your risk of cancer by 2.9 times. Being black or some other race besides white is protective against whatever type of cancer this is. For each 1 pound increase, it increases your risk by 1.3%, and for each 1 year increase in age, your risk increases by 2.3%. Yeah, some other things you can do with proc logistic. You can estimate the risk of just a certain combination of variables. So say for some reason we were interested in the individual risk of somebody who is let's just say black, 30, smoker, weighs 180 pounds. Yeah, I think that's everything. We can say, well, what we're gonna have to do here is we're gonna have to look at how the things were coded. So for race, we're gonna look and see how black was coded. So 1 0, we would put 1 0, and then smoke 1. I can assume weight 180, age 30, and that should and we want it exponentiated, and that should spit out both the estimated risk or odds for this individual, and it should also give you like a confidence whether that's significant. And yeah, so like the risk of this individual is 2.75 times higher than the absolute referent. So yeah, the intercept here would be like a non-smoker, white, age and weight of 0, which now that I'm remembering, I should probably do a video on centering to a more meaningful weight and age, but yeah, I guess these continuous variables, it's usually relative to 0, so the intercept isn't that meaningful here just because we haven't centered age and weight, so you can't be 0 pounds and you kind of can't be 0 years old. But yeah, no, that's how you can do estimates. So yeah, I hope that was helpful. You can also do proc GLM, and I think proc GLM gives a lot of the same options. You wouldn't use prime equals ref. I'm not confident it has, well, it looks like it has an estimate statement. But yeah, that'll give a similar answer, but it won't give nice odds ratios right out without you asking for it. So yeah, I hope that was helpful.